Hello algebra students, and welcome back to another video lesson where we continue to explore quadratic equations and graphing. Today's learning targets really is kind of two parts. You need to be able to graph quadratic equations. One set you need to be able to graph by hand, where it's y equals ax squared plus c. We talked a little bit about that the other day. And then the second part you can graph using Desmos, where we have that standard form. And so make sure you understand and know how to do both of these. And I'm going to walk you through both types of problems here in today's video. So graphing by hand, I'm working from your packet on the bottom of page 11, and you will see there's a couple of checklists. Right, so here's one example for equation 1 and equation 2. What we should do first is fill in the table by hand, meaning we may need a separate sheet of paper for our work to show how we're getting each one of these answers. When I plug in -4, what do I get out? And same thing. Then once we have our table, we need to make a graph from the table and list the characteristics below that graph. We'll talk about what the characteristics are, but you've seen that a little bit. And we really should know what these graphs need to look like. So if the graph isn't really doing what we think it should, then we might want to recheck our work and our table here. And so let's take a look at each one of these separately. Here's equation number 1, y equals -2x squared. What I want you to do is to pause the video, take some time on a separate piece of paper, and see if you can't fill in the y part of this table. When you come back, I'm going to have all of those answers filled in. All right, I hope you took some time to pause and try to figure each one of those out. When I plugged in -4, all right, I'm just going to do -4 so that you can see how I got it. And the others will make sense. -4 squared is -4 times -4, which becomes a +16. And a +16 times a -2 is how I got that -32. And then I did that with -3 and so on. So there's my table of values, which I'm then going to go over here and graph. So -4, -32, and we go all the way down to 0, 0, and then it goes back up. So I got to make sure that I scale my graph here properly. And we're going to go up, actually we're going to go down by 5. So that is -5, -10, 20, 15, 20, 25. Here's -30. Here's -35. So that when I plugged in -4, 1, 2, 3, 4, we went down to 32. So somewhere like in there. When I went to -3, I was at -18, which is like in here. -2 was at -8. -1 was at -2, and then we had 0, 0, and then we had identical things on the other side. So now that we have this kind of roughly sketched out and I've labeled my axis that I'm counting up, that's a bad side, but it's okay, it'll work. We need to identify the characteristics. Well, when they ask you about the characteristics, this is what they're asking you to find. What is the vertex of this graph? Hopefully, you see that the vertex is at 0, 0. What is the axis of symmetry? X equals 0 because it has to go through the vertex on the x-coordinate. What is the y-intercept? Y equals 0. That's where it touches the y-intercept. What's the x-intercept? It's also at 0, because that's the only spot that it touches the x-axis. Does this open up or down? It's got to open down, because it was a -a value. Therefore, if it opens down, what do we call that vertex point? Right here, we say that that is a max. Right? That's the maximum point at y equals, or a maximum at 1. I'm sorry, at 0. It's a maximum at 0. What's the domain? The domain for these are all real numbers. All of them will always be all real numbers. Furthest to the left, furthest to the right, going to go on and on and on forever. What's the range? How does this act on the y? Well, my y values, y is less than or equal, I'll put that on in a second, 0. Y is less than or equal to 0 because the highest y value is 0, and every other y value keeps getting smaller, smaller, smaller. Okay, so hopefully that makes sense. I'm going to have you try another one on our next page. Graph y equals negative x squared plus 5 by plugging in those values into the table. Graph once you're done, and then what are the characteristics? When you get back, we'll have the graph and the table filled in. Okay, I'm hoping you paused the video, filled in the table, tried to graph. We should be careful on this one that we know that it opens down because there's a negative sign out front, a negative a value. Another way to look at this might be y equals negative 1 x squared. Even though there's not a 1 there, there really is, right? Negative 1 x squared. That means when I plug in a negative 2, for example, right? Negative 2 squared is definitely positive 4. But I've got times negative 1 out front. So that becomes negative 4 plus 5, which is positive 1. So when I plugged in negative 2, that's how I got positive 1. That negative sign out front helps to make this open down. Down. All right. Now, the vertex. Remember that 5 shift everything up. So we are now at the point 0, 5 for our vertex, way up here at the top. Where is the axis of symmetry? Well, it's still at x equals 0 because it goes through the middle of this graph and it's that vertical line. What's the y-intercept? Where does this touch the y? Y equals 5. What are the x-intercepts? Well, these ones are a little bit more challenging to find, right? They're just slightly more, and we don't know them because they're not exact points. So we're not going to put anything for x-intercepts on this one. We don't have exact answers. We would have to go to Desmos for that. We know that it opens down, and if it opened down, therefore we have a max at 5. The highest it gets is 5. The domain, farthest left, farthest right, it's going to keep going on and on forever, so all real numbers. And then the range, again, the y values on our graph continue to get smaller and smaller, so y has to be less than or equal to that highest point, which is 5. So once again, to help you graph by hand, you've got to use a table. You're typically going from negative 4 to 4, maybe negative 3 to 3, and then answering those characteristics. Now, what happens when we get more complicated ones in standard form? Y equals x squared minus 4x plus 3. I would maybe pause and jot these notes and steps down because this is really what we're going to go over to Desmos and do and really complete. All right, so y equals x squared minus 4x plus 3, and we're going to try and identify those characteristics. So if I go to Desmos, and I grab their graphing calculator, we're going to type in x squared minus 4x plus 3. And there we go. Now remember, to get the squared part, you're using Shift and the number 6 on your keypad. And if I want to try and find some of these clear identifications, you can see that they're a little bit grayed out. 0, 3, 1, 0 there. And if I click on them and highlight them, they will all show up. So then what I'm going to do is grab a quick screenshot and move that over to my work area right in here so that we can answer our questions. Where is the vertex of this graph? The vertex is at that point 2, -1, way down there on the bottom. Therefore, what's the axis of symmetry? X equals 2. Again, axis of symmetry is always X, and it's whatever my vertex is, because it's going to have to go through the vertex. That's where the change in direction occurs. What is the y-intercept? Where does that graph cross the y-axis? That's at the point 0, 3, clearly labeled right there. What's the x-intercept? Well, in this problem, we actually have 2. Oops. 1, 0, and 3, 0. Right? We can see that it crosses that x-axis twice, once here and once there. We should have been able to answer this question right away. It opens up. We didn't even need to graph it because the a value in front was positive. If it opens up, we have a minimum value at -1. The smallest y value is -1. So a minimum value at -1. The domain is all real numbers once again. Always going to be all real numbers for domain. But the range in this case, the y values or the graph gets higher and higher and higher. So the y values will be greater than or equal to, what's that smallest y? What's the vertex? -1. Okay, so y is greater than or equal to a -1. I'm going to give you another one to try. Copy this down on a piece of paper, go over to Desmos and try to graph it and see if you can't get these questions answered. So pause the video and try that here. All right, hopefully you got a graph that looks similar to the one that I have here on the left. And this is why using Desmos is so helpful, because some of these numbers are kind of weird, right? So what's the vertex? Well, according to that graph, we've got -0.714, 12.143 as our vertex, right? It is right there. Vertex, right there. Therefore, what is the axis of symmetry? Well, the axis of symmetry has to go right through the middle of our vertex at the x spot. So x equals -0.714. It's got to be the x. What's the y-intercept? There it is, 0, 5, but it's also the c value. So 0, 5, we see it in the equation. What are the x-intercepts? Well, there they are. Again, they look a little different, but -1.646, 0. And then we've got 0.217, 0. So you can see why using Desmos is so helpful. This definitely opens down. We had a -a value. If it opens down, that means my vertex up there is the highest point, so it's a maximum point at 12.143, because that's the highest point we have. The domain, probably getting sick of hearing it, but the domain is always going to be all real numbers. And the range, well, it's y. Because we have a maximum, and that's the highest spot, all of the y's have to be smaller, which is less than or equal to, what's that y value up there? 12.143. Y is less than or equal to 12.143. So hopefully you understand the differences between graphing by hand and graphing using Desmos and how to process or use the different steps for each one. If you have any questions, please make sure that you do indeed reach out. Otherwise, until next time, everyone, stay safe.